Hello friends, in this video, let us discuss about BFS. So we have learned about graphs. So how can we traverse graphs? That is, visit every node of the graph. We have two major methods for that. One is breadth first search BFS and next is depth first search DFS. In this video, let us discuss about BFS. In BFS, we use a queue data structure to traverse the graph, that is, to visit all the vertices. Simply, let us understand how it is done. Let us start from vertex A. So visit A, insert it into the queue and add it to a visited array also. In this array visited, the vertices that are visited will be added. Now it has A only. It means only the vertex A is visited. Now take the vertex A from Q and visit all its neighbors, which are B, C and D. So these are inserted into the queue and added to the visited array also. Now A and its neighbors are visited. Now take the next element from the queue, which is B, visit it and visit its neighbors. The neighbors of B are A, D and E. But A and D are already visited. Only E is not visited. So add it to the queue and the visited array. Now B and its neighbors are visited. So take the next element C. Its neighbors are A and D. Both are visited. So just move to the next one D and its neighbors are A, B, C and E, which are also visited already. So take E. Its neighbors are B and D. Again, both are visited. Now, there are no more elements in the queue. So we can say all nodes of the graph are visited now. So this is what BFS traversal is. We start from a vertex or node, visit it, visit all its neighbors, then visit all its neighbors and so on. So let us see how to implement it. First, let us define the size of queue as 25. Next, we have some functions. We have the isQEmpty function here to check whether the queue is empty or not. If the queue is empty, this function returns 1, else it returns 0. We have if front equal to rear return 1, else return 0. Next, we have dequeue function to perform deletion from the queue. When this function is called, the element at the front of queue will be deleted. Next, we have the enqueue function to insert an element into the queue. When this function is called by passing an element, it will be inserted at the rear end. But defining all the functions is difficult and makes the program very long. Instead, we can simply include the queue.h file, which has the inbuilt functions for queue operations. So we include queue.h and define the size of graph V as 5. Now in main, let us define the graph as an adjacency matrix. So we have ARR of VV equal to these values. So the graph is defined. Now let us call the function BFS by passing this adjacency matrix ARR and the starting vertex. We can start from any vertex. Here we will start from the vertex 0. So control gets here and ARR is stored in ARR and 0, the starting vertex, is stored in source. And as we know, for BFS, we need two data structures, a queue and a visited array. So declare the array is visited of size V, that is 5, and initialize to 0. Now declare another integer variable index. Now, the first step is to insert the starting vertex to queue and make it visited. So write enqueue of source. So 0 is inserted into the queue. Now make it visited in the isVisited array. So isVisited of 0 is made 1. Now we have to visit all its neighbors. Use a while loop for that till the queue becomes empty. First, remove the element from the queue and store it in node. So 0 is dequeued and stored in node. Now print 0 is the visited node. And how can you find its neighbors? Say this is vertex 0. If there is an edge from 0 to 1, 1 is a neighbor of 0. And if there is an edge from 0 to 2, 2 is a neighbor of 0. And if there is an edge from 0 to 3, 3 is a neighbor of 0, and so on. And how can we check that here? We can simply check the adjacency matrix. Which all columns are having the value 1 in 0th row? We have 0, 1 equal to 1, 0, 2 equal to 1, 0, 3 equal to 1, and 0, 4 and 0, 0 equal to 0. So we can understand that 1, 2 and 3 are neighbors of 0. So this is the logic. So use a for loop. We have for index equal to 0, index less than v, index plus plus. And in first iteration, index is equal to 0. Next we have if ARR of node index equal to 1, that is whether index is a neighbor or not. And is visited of index equal to 0, that is we are checking if it is already visited. So if index is a neighbor of node and if it is not already visited, we have to add it to the queue and make it visited. But here we have ARR of 0, 0 equal to 0. So if fails, and in next iteration index is equal to 1 and ARR of 0, 1 equal to 1 and is visited of 1 equal to 0. That is 1 is not visited yet and it is a neighbor of 0. So insert it into the queue and make it visited. So is visited of 1 equal to 1 now. Now in next iteration, index is equal to 2 and ARR of 0, 2 equal to 1 and is visited of 2 is 0. That is 2 is not visited yet and it is a neighbor of 0. So insert it into the queue and make it visited. So is visited of 2 is equal to 1 now. Now in next iteration, index is equal to 3 and ARR of 0, 3 equal to 1 and is visited of 3 is equal to 0. That is 3 is not visited yet and it is a neighbor of 0. So we have to insert it into the queue and make it visited. So is visited of 3 is equal to 1 now. Now in next iteration, index is equal to 4 and ARR of 0, 4 is equal to 0 and not equal to 1. So if fails, and in next iteration index is equal to 5 which is not less than v. So condition fails and control comes out of the for loop. So what have we done here? We started from vertex 0. We visited it and visited all its neighbors also. Now in next iteration of while loop, remove the element from queue and store it in node. So 1 is dequeued and stored in node. Now print vertex 1 is visited. Now we have to visit all its neighbors. So again use the for loop. In first iteration, index equal to 0 and ARR of 1, 0 equal to 1. That is okay, but is visited of 0 is equal to 1 and not equal to 0. That is 0 is a neighbor of 1 but it is already visited. So if fails and in next iteration index equal to 1 and ARR of 1, 1 equal to 0. So if fails again and in next iteration index equal to 2 and ARR of 1, 2 equal to 0. So if fails and in next iteration index equal to 3 and ARR of 1, 3 equal to 1 but is visited of 3 is already 1 not 0. So if fails again and in next iteration index equal to 4 and ARR of 1, 4 equal to 1 and is visited of 4 equal to 0. That is 4 is a neighbor of 1 and it is not visited yet. So insert it into the queue and make it visited. So is visited of 4 equal to 1 now. In next iteration, condition index less than v fails and control comes out of the for loop. In next iteration of while loop, the queue is not empty yet, so continue and dequeue the next element which is 2 and store it in node. Now print 2 is visited and visit all its neighbors. But if will fail here in every iteration since is visited is 1 for every index. So in next iteration, dequeue the next element 3 and print it is visited. And again if will fail for every iteration of the for loop, since all nodes are already visited. So in next iteration of while loop, delete the element from queue which is 4 and print visited node is 4 and again same happens. Now in the next iteration of while loop, the condition not is queue empty will fail since the queue is empty now. So control comes out of the while loop and the traversal is completed now. Now one question to you. Why did we use the isVisited array here and what will happen if we didn't use it? See, a traversal means we have to visit each node. If we hadn't kept track of visited nodes, we would visit it again and again. And unlike trees, graphs may contain cycles and we will get into an infinite loop. So using this Boolean array isVisited can avoid such issues and each node is visited only one time. So this is what BFS is. And in the next video, we will discuss on DFS or depth first search traversal.